Got it. All right. Stop this thing. And let's start out. Let's hop back over here really quickly. Okay, we got these gentlemen. Let me share my screen. Start the broadcast. Okay. I'll check attendance again for anybody that's coming in late. I'll check it again in about 10 minutes at around 3:15. Let me see. As far as announcements, no major announcements other than we're at the end of week 6. We can anticipate exam 2, i.e. the midterm. There's not really a midterm. It's just exam 2. But we can anticipate that to become available right before the start of week 8. So I think I scheduled it to become available that Sunday at 11 a.m. right before week 8. So this is week 6. Next week will be week 7. We'll just do the next section. And then after that, exam 2, you can anticipate it to cover the material from weeks 5, 6, and 7, right? As usual, this is remote asynchronous. So if you've gotten your attendance credit, you're not obligated to stay. I might throw a little bit of hissy fit, but the agreement is, as long as you get your attendance credit on each day, you're checking in. So I know that you're alive, you're well, you're okay, because I have had things happen to students and, we'll let that be. But that's why I at least need you guys checking in. Periodically, I have administrators come and say, hey, when was the last time you've seen so-and-so? So then I just check my records. Attendance is more so for records, and it only becomes an issue when you hit about like 3 unexcused absences, because then you can be booted from the course and some other stuff. And, it's kind of a headache, and it can really mess up your money, but we don't really want to do that. But otherwise, it's really just for record keeping. As always, as we go forward, if you have questions or if anything is not clear, feel free to unmute yourself. That's the best way to get my attention, so we can, we can kind of get to the bottom of the confusion. My philosophy is the only dumb question is the one not asked, right? So a closed mouth doesn't get fed. So if anything isn't clear, just speak up. We might be doing something a little bit different today. I do want to kind of make my way through as many of the homework questions as possible, right? So that's what we have here. But periodically, let me see. Oops, this is not the right one. Did I click on? Come on. We're not in week 7. View. Allow. We are in week 6. This one. Okay. Yeah, we might be doing something a little bit different whenever there's, like, for instance, this one, right? What we've been doing with the other classes, we've been using this guy right here. See participants. So, for instance, whenever it's multiple choice, what I like to do is launch a poll, right? So I just launched a poll. And the poll is like, okay, is the answer going to be A, B, C, or D? So I usually don't, let me see, if I want to 30%, right? Yeah, that's fine. So we got a more intimate group, so that's fine. I usually don't move forward or don't submit an answer till I have at least 30% participation. So with it being such an intimate group, that's only 2 people, right? Let's go 50% since it's so small. So 3 people, right? We just need 3 of the 6 to answer, and then we can submit it, talk about it, and move forward. Otherwise, I'm just going to try to fill the air, until we get 30% participation. So in this example, it says describe the transformations, and I think the poll is like anonymous, right? I mean, there is a way for me to pull it, but for the most part, it's anonymous. And you can actually change your results too once you choose something. So starting with the basic function square root of x, for part A, we want to see how do we go from f to g, right? So square root of x is basically the top half of a sideways parabola. Notice that plus 3 is outside of our basic function, right? So if we're adding 3 on the outside, should the answer be A, B, C, or D? Outside manipulations typically cause a vertical change and follow our intuition, right? So if we're adding 3, and I'm really just waiting for the poll for you guys. The poll is actually on Zoom, right? So if you go to Zoom, I need at least 3 people for right now to is a result A, B, C, or D. So if we're adding 3 on the outside, that's going to affect our Y value, all right? We got 1 taker for B. So if the 3 is on the outside, that means it's affecting our Y value, all right? The X's should stay the same. If it's affecting Y, that means it should be a vertical change and it should follow our intuition. I need at least 2 more people. I need at least 2 more. Okay, I need 1 more. And now there's a vote for D. So we got between B and D, we need 1 more. What do you think? B or D? Or something else, if you feel like it's a different one. We need at least 1 more. Okay, I guess
actually, I want to change my answer to C.
Is it
down?
You should be able to change it. Just like it's not letting you do it. Yeah, you should be able to change it. Is it letting you change it? No, I guess not.
Nah, it's not. It's not letting me change it.
Well, that's good to know. I didn't know that you couldn't, but that's okay. So with it being so intimate, let's go ahead and go with D. All right, we're gonna just let that be for now. Okay. Because part of it was, let me reload the poll. So it's good to know that you can't change it. Launch. Okay. I was chatting with my previous course and I was like, I'm considering extra credit. I haven't fully committed to it yet, especially like on days like today when it's like a few number of students. These are prime days when I was doing extra credit. In the past, when I was doing extra credit, you can earn up to like 10% of your overall grade, not in one go, but throughout the whole entire semester. So I shared with this class earlier, I was like, well, I might be a little bit more open to extra credit after exam 2, right? But yeah, days like today when we have all these people that showed up to get their attendance credit, and instead of getting upset about it, I was like, okay, let's try to take care of the people that are here and engaging, right? But I'm still kind of on the fence about it, but we'll let it be for now. So for part B, we have the square root of X and we're subtracting 5 on the outside, right? So outside manipulations typically cause a vertical change and follow our intuition, right? So there's 1 vote for D. So if you're subtracting 5, that should affect, let's try to get at least 1 more. We can get 2 out of 4 is not bad. So D says shift 5 units down, right? So the -5 is on the outside. The outside should affect the Y values. So it's like basically each Y value, we're subtracting 5 from each Y value. So I can get down with D. Let's go with it for now. All right. And let me end the poll. And I just want to see who's engaging.
I'm just confused how it's 5 down from that.
Okay, give me just a moment. That's not.
Can I say something?
Go ahead. Give me just a moment.
Okay.
I just want to view. Cool. Come on. All right. So let's see. So 5 down, right? So that -5, the basic function here is square root of X. That -5 is outside of the square root symbol, right? So it's outside the function. So that when we're doing manipulations on the outside part of the function, that's going to affect our Y values. So then it's like we're basically taking each Y and subtracting 5 for each Y. The X values stay the same. So the way that it affects the graph is it moves the whole graph down by 5 units. I know there was another question. I don't know if we had answered or not, or if we were successfully able to answer the first question. Okay, let's try another one. Okay, so let me relaunch the poll. So relaunch. Okay. So again, and I want to say the poll for the most part is anonymous unless I decide to like pull the results, which I did in the previous. So I can see who's engaging. But yeah, so this was where I said describe the transformations of the graphs of G and H from the graph of F. There is a vote for A. We need at least 1 more. We're starting with f of x equals the absolute value of 2x. For part A, we're multiplying the outside of our function by a negative, right? So we just said that outside manipulations typically cause a vertical change and follow our intuition. So if we're multiplying the outside by a negative, that's like our Y values are going from positive Y to negative Y. The X's are staying the same, but the Y's are going from positive Y to negative Y. So if our graphs are flipping from positive y to negative y, then let's see, there's a vote for A. And let me get at least one more person to vote. All right. So, okay, there's a vote for C. Let's see, vertical stretch. All right. So if we're multiplying the outside by a negative, the y's are going from positive y to negative y. We're not distorting the shape. We're just changing the orientation. So outside manipulations typically cause a vertical change. I'm just going to go with B. All right. So let's go with that. Let's keep going. Let's relaunch the poll. Launch. And, you know, with this information, you know, like at some point you're going to be responsible for this information, right? So, I mean, however you get through it, I understand. It's totally okay. But just be aware that at some point you're going to be responsible for it. So you don't want to just like waste your time, you know? Still do it. I wouldn't be mad at you for doing what you need to do, but try to make sure that you're understanding on some level. Because you don't want to be here and get through it, but then get held back because you don't really get it, right? That's a waste of your time and money, right? If it were up to me, I would kind of change things a little bit, but certain things are out of my control right now, so it is what it is for right now. For part B, we're multiplying the inside by a negative, right? So outside manipulations typically cause a vertical change. Inside manipulations typically cause a horizontal change, right? And so I can understand that like class time and getting it from the professor can be a challenge. Believe me, I was there, right? But if you're not going to get it from me, this is why I encourage you guys to work together. If you can't get it directly from me, then maybe you can get it from a classmate and it's fine. Maybe you can get it from a tutor, right? You know, and it is what it is for right now, but that's why I'm trying to make myself available. I do have colleagues that like, you know, with these kind of remote classes, they just post the material and they never go live. Like they might hold office hours and it's just mute and they just sit there, right? And I could do that. I just choose not to. It's just not what I want to do. But I could just like, okay, everything is there. I'm here for questions and leave it at that. So with part B, we're multiplying the inside by a negative, right? So that should cause a horizontal change. Is our y values should stay the same, but our x's go from positive x to negative x, or vice versa, right? So it's only affecting the x's. So if x goes from positive x to negative x, it should be flipping over the y-axis. So we're going to go with D for now. Let's see how we did there. Okay, let's try now. Okay, I think this one is not multiple choice. Describe how the graph of the following function can be attained from one of the basic graphs. So we're going to be starting with the reciprocal function 1 over x. We're multiplying this by 10 on the outside, so that's going to cause a vertical stretch. So we're going to stretch it vertically by multiplying each y value by 10, all right? And we want that to be 10. Can we type here? What if I go like this? I might have to reboot this thing. Let me turn this off. Okay. All right, let's try another one. Graph this function, right? So we're starting with, here, we're not doing a poll just yet. We have y equals x squared minus 6. So the base function here is x squared. That minus 6 is outside of our basic function. So then it's basically a U-shaped curve that went down by 6. So I'm going to click on to enlarge. A U-shaped curve is a parabola, which is the upper right-hand corner. I'm just going to click on the origin. I just clicked on the graph. And the only manipulation is we went down by 6. So we did a vertical shift of -6. I'm gonna hit save. So it's a U-shaped curve that came down. And we got it. Let's go on to the next one. So this one, okay, this is one we could do a poll. I need at least 2 people. All right. So we're asked to graph y equals the square root of x plus 3. Notice that plus 3 is outside of the square root. Outside manipulations typically cause a vertical change and they follow our intuition, right? So square root function should be the top half of a sideways parabola, right? So if I can get two people, should this one be A, B, C, or D? Which one is the top half of a sideways parabola where we added 3 to all the y values? So is it either A, B, C, or D? Is it A, B, C, or D? All right. Okay, we got one. Well, I guess you guys are like comfortable doing this on your own. I'm gonna just go into the next one until I get another vote on this one. You know, because I guess you don't want me to go through it. So we need like one more person. A, B, C, or D. Well, I'm not gonna worry about it. Let's see. I got another one. So let me just go into the next one. I'm going to go ahead and restart the poll. I'll just talk about them, but if y'all don't, if I can't get any responses, then I'm not going to worry about it. So let's go into the next one. So I'll just, like, if I need at least 2 people, it's 4 people on the call. I know I can get at least 2 to respond. So this one says use transformations to graph the following, right? We got the absolute value of x where we have, we're subtracting 6 on the inside, right? So is this one A, B, C, or D, right? So I'll give it like a little bit of time. If I don't get at least 2 people, then I'll just go into the next one. I might chat about it a little bit. We got the absolute value of x, right? We're subtracting 6 on the inside. Inside manipulations typically cause a horizontal change, and they're typically the reverse of our intuition, right? So if we can see these graphs, which one of these caused the horizontal change and is the reverse of our intuition, right? So we're subtracting 6 on the inside. Which one of these caused the horizontal change that incorporates that -6? I'll give it like a minute or 2. Let's check it out. Okay, we got one. This one. Okay, cool. Oh, let me see. Okay, so I can get no, right? It's not D. Because we said subtract 6 should cause a horizontal change, right? So that should go to the right by 6, right? Because it's the reverse of our intuition. I'm going to go with C just for the sake of time. Let me see. Because I mean, you know. Okay, so let's try the previous one. Let me reload the poll. Let me relaunch it, and let's try the previous one. I'll kind of let it be for now. Launch. Okay, so if we go back to the previous one, we had the square root of x plus 3, right? So we have the square root function, and that plus 3 is on the outside. So how does that affect the graph? Does it move it up? Does it move it right? Does it move it down? Does it move it left? So we said the outside manipulations typically cause a vertical change and follow our intuition, right? So should this one be 8? Which one caused a vertical change going with our intuition? Square root of function is like the top half of a sideways parabola. So then which one of these, and you know, it doesn't hurt anything to guess, right? It doesn't hurt anything to guess. I'll give it like a minute or two. And, you know, same kind of deal, right? Let me see, I left off here. Oh, that would have been nice. I didn't touch it. Okay, we need one more. Ah, boo. Glad that's over. All right, so I don't know. I'm just gonna skip that one. Then it's like just guess. It's not gonna hurt you to guess. All right, let's try this one. This one is not multiple choice, so I'm gonna just kind of end that poll. Let me see who we got participating. View. I just want to view. Not like that though. Just want to view. Yeah. Okay. That's what I thought. Okay. All right. So let's give this one a go. Let me kind of relaunch the poll. Let's see. So graph the function by starting with the function from the library. Okay. So this one, the base function is x squared, right? And I see two transformations. Let's get rid of this for right now. There are two transformations. We subtracted 4 on the inside and added 3 on the outside, right? So to list out those transformations, if it's x squared, we're starting with a U-shaped curve. I'm just clicking on the graph. I'm clicking at the origin or whatever. There it is. So when we do multiple transformations in one graph, the recommendation is to work your way from the inside to the out. So the innermost transformation is the -4. That tells us that we're going to the right by 4. Horizontal shift to the right by 4. So I'm just dragging this over to by 4. And then +3 is on the outside, so it's going to go up by 3. And that's it. It's just a U-shaped curve that went right 4 and up 3. Okay, let's check. On to the next one. This one's similar, right? So let's click to enlarge. Instead of the parabola, instead of the U-shaped curve, it's the cube, right? So it's an S shape. So it's kind of like this one on the third row on the left. I'm just clicking on the origin. Now the transformations, first we have that negative times negative and multiplied on the outside, right? So multiplying the outside by a negative, basically what it does is it causes our y values to go from positive y to negative y. So it flips vertically over the x-axis, okay? Then we're saying +2, so that's gonna cause a vertical shift. It's gonna go up vertically by 2 units. So we're just gonna change that to a 2, hit save. That looks good, and I'm gonna check. Okay. Let's see what else we got. Transformations for this function. Okay. So this one has, I see 1, 2, 3, 4 transformations, right? The base function here is x squared. The base function here is x squared. Okay. So I'm gonna start with my U-shaped curve. Now, this was a little bit different because they want us to plot points. It's not like we could start at the origin and then manipulate it to do the transformations or whatever. So they want us to plot points. So before we plot, we can kind of track the vertex, right? Normally, the vertex, you know, is a U-shaped curve where it starts at the origin. But then that -6 tells us to go to the right by 6, and then that +2 tells us to go up by 2. So then the vertex will be right 6 and up 2. I'm going to click on that point. And then for a second point, I'm going to say consider when x is 7. I just went to the right by 1, right? So when x is 7, I'm going to find my corresponding y. 7 minus 6 is 1. 1 squared is 1. 1 times -4 is -4. Negative 4 plus 2 is negative 2. So when x is 7, y is negative 2, right? And then that's what I would submit. So, and if you think about it in terms of transformations, we started with a U-shaped curve where the vertex was at the origin. We went right by 6. We did a vertical stretch by a factor of 4. We multiplied the outside by a negative, so it flips vertically over the x-axis, and then we go up by 2, and we're here, all right? So that one had 4 transformations in one go, and this should be it. Let's check it. Okay, let's try another one. All right, so the ball is in you guys' court, you know? If you want to keep moving, I just need at least some clicks, at least 2 people. Let's start let's launch the thing. Okay, cool. Yeah, if you're not, it's like, yeah, that's the thing. My thing is, it's like, if you're not going to engage, if you don't want to engage, ask question to actually get anything out of this, and you don't have to stay, like, to me, what are you doing? Like, if you're going to be here, engage. If you don't want to engage, you don't have to stay. Like, it's okay. Like, it's totally okay. So I just don't want to waste people's time and energy. Like, if you don't need me to say this stuff or share it, let's not waste each other's time. Like, that's just how I feel about it. But if you do want to hear what I have to say, I think we should engage. Like, I'm not saying this because I don't need it. Like, I already know this stuff. And you've already paid me. Like, you've already paid me. So it's like, I'm just here. But let's give this one a go. But again, I'm just trying to cover my tracks. Like, if you've paid me, then let me at least go out of my way to, like, be available. Let me at least make myself available. You know, I'm here now. Now, towards the end of the semester, I don't know what's going to happen there. I mean, whatever's there is there. But the best thing is try to be done with everything now, so that you're not trying to, like, save face at the end of the semester. Because at the end of the semester, it's going to be over. Like, that's it. So this one, we're starting with absolute value of x, right? I see 1, 2, 3 transformations, right here. I don't want to suppress that though. So now, I still need 2 people, right? We're doing transformations. We're starting with the v. It's either A, B, C, or D, right? There's 3 transformations now. When we're doing multiple transformations in one function, the recommendation is to work your way from the inside to the out. So normally we'll start with the v at the origin. That plus 3 tells us that we need to go left 3. That negative on the outside tells us we need to flip vertically over the x-axis and then go down 4. So which one of these options started with the v? Yeah, started with the v, went left 3, flipped vertically, and then went down 4. And let me get at least one more person. Let me see, and I think it's the same person. Like, there's really only one, there's only, I don't want to get into all of that. Let's go with that for now. Okay, cool. Yeah, right? Because we just went left 3, flipped vertically, and went down 4. That's cool. Okay, let's go with that one. So we're going to let that be. Next question. Okay, so this guy, right? So when we were going through the lecture, let me restart the poll. Relaunch. And I am going to pull some data in just a moment. Okay, so when we were going through the lecture, we didn't get an opportunity to talk about this one together. This is called the greatest integer function, right? This one is in my pre-recorded lecture, but together, we only had but so much time. So I know we didn't get a chance to talk about this one, but you're responsible for it. So this is called the greatest integer function. And what it means is whatever value you have inside that symbol, you're going to take the greatest integer less than or equal to that number. For instance, the greatest integer less than or equal to 2 is 2. The greatest integer less than or equal to 7 is 7. The greatest integer less than or equal to 10 is 10. The greatest integer less than or equal to -3 is -3. So the first part is whenever you have an integer on the inside, you just take that in, right? Then another scenario is whenever you have a number that's between 2 integers, you take the integer to the left, right? So what I mean is, like, for instance, the greatest integer less than or equal to 2.2 is 2. The greatest integer less than or equal to 7.65343 is 7. right? Because 7.65343 is between 7 and 8. The greatest integer less than or equal to 6.5392, right? 6.5392 is between 6 and 7. So the greatest integer less than or equal to 6.5392 is 6, the integer to the left, right? Let's do a couple more. What's the greatest integer less than or equal to, suppose we did -1, right? We said when it's an integer, you take it. So that would be -1. What's the greatest integer less than or equal to -3.456? So let's say it again. What's the greatest integer less than or equal to -3.456? So if you think about -3.456 is between -4 and -3, right? So then the integer to the left is actually going to be -4, right? So, when you're working with negatives, it gets a little bit loopy, but again, to recap this symbol, what it means is whenever you get an integer, you just take that integer as is. Whenever you get a number that's between two integers, you take the integer to the left on the number line, right? Okay. So hopefully that kind of sunk in. So when you look at the graph of the greatest integer function, it looks kind of like this. We call it a step function because the graph looks like the steps on the staircase, right? That's just the way it looks. It just looks like the steps on the staircase. So if we want to consider the transformations here, there are two transformations at play. The first thing that we did, we had that -2 on the inside of our function, right? So what that's going to do is going to shift the graph to the right by 2 units. And then that 3 on the outside is going to cause a vertical stretch by a factor of 3. So we went to the right by 2, and we caused a vertical stretch by a factor of 3. So of these 4 graphs, and I feel like at worst case scenario, it should be a 50-50 guess, like even if you had to guess. But which one of these graphs do you think was stretched vertically? We made it taller and skinnier by a factor of 3, and we shifted it to the right by 2. Right? Let me get at least 2 people. Which one of these 4 do you think we shifted to the right by 2 and we stretched vertically by a factor of 3? Even if you had to guess, what 2 do you think? And I want to say, like, if you're not sure, you can like choose an X, plug it, pass it through this function, and test it. I'll give you like a couple of minutes. It's just, it's just a guess. It's not it doesn't do anything. No, I don't care about that. Take this. Okay, so we got 1 for C. I like the way that C is looking, right? Because, and I'm still looking for 1 more. I'm just filling the air. Oh, well, this is okay. I can get down. We got somebody. That's what I needed. I like either somebody needs to engage or, I don't want to waste anybody's time. Okay, so I can go with 50%. I think we can get some movement going now. Let's see. So if we go right by 2 and we stretch, so it shouldn't be A or D, right? Because those have been smushed. A and D have been smushed. So that's why I was saying it should be a 50-50. So then it should be either B or C, right? So then there's a vote for C. So let's see. If we went to the right by 2, when X is 2, we should be at 0, right? So 2 minus 2 is 0. Greatest integer less than or equal to 0 is 0. 0 times 3 is 0. So when X is 2, Y should be 0. So then between B and C, that means it should be C. So let's go with C. Okay. All right. Next question. All right, so let's do this one. Write this function whose graph is the graph of this, but it's shifted to the right by 5 units. So if we're moving side to side, that means we need to do an inside manipulation. And if we're going right by 5, that means we need to subtract 5 on the inside, right? So this guy here, let's see if we can try to recover some of the stuff. So let's go square root. It should be x minus 5. I'm gonna just hit enter. Okay, let's go on to the next question. Let me see, did we finish that one from earlier? Let's go back to that one that we skipped. Since there's only two of us, if I can get one person to participate, that works for me. Relaunch. Okay. Graph this function, right? We got square root. It chose A. Yeah, it looks good, right? Let's just go with it. Check the answer. Come on. Boom. Okay. And then let's go down here. Let's try to make up for some of the lost time. Write an equation for a function. Okay, so yeah, this one is multiple choice. Let me relaunch it. Like, I don't understand the intimidation factor. Like, I get it, but it's like nothing happens. Like, I don't understand why put this off. Like, if you're responsible for, I mean, there's a number of things though that could be in place. So I was just like, well, I'm trying to just let you guys be adult about it and like, just do what you need to do. So with this one, it says the shape of x squared, but it's upside down, shifted to the right by 7. Okay, and then up 8 units, right? So which one of these is a U-shaped curve that's upside down where we go right 7 and up 8? Right? Is it A, B, C, or D? Where we go right 7 and up 8? Right 7 or up 8? B. Let's see. No. I don't think B is correct. Right? So let me see. If we're going right by 7, that means we need, so remember, we said inside manipulations are horizontal changes, and it's the reverse of our intuition. So even though we're going to the positive 7, in order for it to have that effect, we need to subtract 7 on the inside. So subtracting 7 on the inside and going up by 8, let's go see. Okay, let me relaunch the poll because I think we have some more coming up. Relaunch. Like, even if you guess, it's okay. Let's go to the next question. That one's not ready. Let me see. The graph of this is shifted 3 units to the left, stretched vertically by a factor of 4, reflected in the y, and shifted 6 units up. Okay. And like at one point I was like, well, maybe I should take away their attendance. But the only reason I don't do that is because I was like, no, that wasn't the agreement. The agreement was as long as they check in, they're not obligated to stay, right? I didn't say that they had to engage. They just needed to check in. So I was like, okay. So that's the only reason I didn't be like, okay, well, let me undo this attendance. I was like, no, they did what I asked them to do. So I was like, okay. I like the poll because it's, for the most part, is anonymous. You don't have to say anything, just click, right? If you're engaged. I'm trying to get you guys to engage without. But anyway, the graph of this. So let's start with something like this, to the power of 3, and we want to get back here. Okay. So we're starting with x cubed. It says shifted 3 units left, right? So if we're going left, 3 units left normally would be -3, but it's the reverse of our intuition. So let's do +3. So there's 3 units left. Stretch vertically by a factor of 4. So since it's a vertical, we need to be on the outside. So that means we're multiplying by 4. Reflected in the y-axis, that's a horizontal flip. So I'm going to put my negative right here and shifted 6 units up. So that means we're adding 6 on the outside. That's not right here, right? Let's go with this. Cool. All right. Okay, let's try another one. What's the time? We got time for like one more, right? Yeah, I think you guys are the first one to do this, make it this far. Use the graph of this to graph the function. Okay, so this is the graph of f. So then, even if you had to guess, we're adding 3 on the outside, right? So outside manipulations affect the y values. It's like adding 3 to all the y values. So which one of these graphs captures adding 3 to all the y values? Is it A, B, C, or D? A, B, C, or D? Right? I feel it's the same thing, right? So let's go with that. Let's check it. Okay, cool. Let's go on to the next one. Let's see. What is this? This is the graph of f, and g is basically going to be f of half of x, right? So now we're multiplying the inside by a number between 0 and 1. So inside typically causes a horizontal change and is the reverse of our intuition. Intuitively, you might be thinking, might feel like you want to say, oh, a horizontal compression because that number is between 0 and 1. But in reality, it's going to have the reverse effect. So it should cause a horizontal stretch by a factor of 2. Should cause a horizontal stretch by a factor of 2. So which one of these causes a horizontal stretch by a factor of 2? So A looks like it's been smushed some way. Also C looks like it's been smushed. D looks like it was stretched vertically. So by process of elimination, I'm going to go B. Oops, check the answer. Okay. All right. Let's do one more if it's quick. Let's see if it's quick. Okay. We're subtracting 4 on the inside, so it should be the same graph but shifted to the right by 4. The only one that went right by 4 is C. Check. Okay, cool. All right. So I have that it's that time, right? You know, I'm just gonna leave it as is. I'm not gonna stress it. It is what it is. Let's see. So again, we can anticipate exam 2 to come about before the start of week 8, right? So it's there, you know, everything is there. If there aren't any burning questions, we're going to end the session here, and from one beautiful mind to another. Enjoy the rest of your day, guys. Okay. Take care. Peace.